In this tutorial, we are going to solve questions under vibration and wave as well as sound wave. Okay, so I've got a number of questions with me here, and these questions I've gotten them from different past papers for semester 2. The past paper for 2018, 2019, 2020, 2022, and 2023. So I'll only solve the the questions under vibration and wave and also sound wave. Then the next video I'm going to solve the questions under the electric field and forces and also the capacitance. Okay, so let's begin our discussion with the first one. So the first question is saying a 0.35 kg object attached to a spring of force constant 1300 newton per meter is free to move on a frictionless horizontal surface. If the object is released from rest at x is equal to 0.100 meters, find the force on it and its acceleration at part 1 at x is equal to 0.01, part 2 at x is equal to 0.050, part 3 at x is equal to negative 0.02 meters. Okay, now how do we find the force? We know that the resultant force is given by kx. Okay, in this case we are just finding the force. Okay, so it is okay for you not to include the negative, it's fine. So we'll say F will be equal to the K is the spring constant, which is 1300. Then the X, now for part 1, the X is 0.1. Okay, so my force will be equal to, I'll say 1300 times 0.1, that is 130. 130 newton. Now, when the force is 130 newton, what will be the acceleration? Force is equal to mass times acceleration. I want to find the acceleration. You can divide both sides by mass, both sides by mass. Acceleration is equal to the force is 130. The mass is 0.350. So our acceleration for the first part will be 130 divided by 0.350. That is 371.43 meters per second squared. Now, you know, sometimes since we are talking about when the spring was being stretched and released, you can also assume that this is the maximum acceleration. So you can also use that formula for maximum acceleration and you end up finding the same answer. What do I mean? The formula for maximum acceleration starts from here. We know that the resultant force is equal to kx. So where there is force, I can replace it with the ma. So ma is equal to kx. Divide both sides by m, both sides by m. A will be equal to kx divided by m. So if I plug in the values here, I should get the same answer. Okay, the x is 0.1, then the m is 0.1, sorry, 0.350. So the acceleration here will be 371.43 meters per second squared. So we end up having the same. So even if I use this formula or the other one, force is equal to mass times acceleration, I will end up getting the same answer. Okay, so that is it for the first part. Now the second part, you can pause the video, find the force and acceleration, and let's see if you're going to get it correct. So now there we go. We say the force will be given by kx. The k is 1300, the x is now 0.050. So we end up having 1300 times 0.05, that is 65 newtons. What is acceleration? So the acceleration will be given by the force divided by the mass. So the force is 65, the mass is 0.350. So acceleration will be 65 divided by 0.350. So I'm getting 185.71 meters per second squared. That is the answer. Let's go to part 3. So part 3, we use the same formula. Force is equal to kx. Now the k is 1300, the x is negative 0.02. So what will be the force? So it will be 1300 times 0.02. So this is going to give me negative 26 newtons. Because this is negative, so it's going to be negative. Now what does it mean? This negative is just showing us to say the object was now going in opposite direction. Okay, so now how can we find the acceleration? Acceleration is equal to the force divided by the mass. So the force is negative 26, the mass is 0.350. Acceleration is going to be equal to 26, we divide it by 0.35. Okay, so we end up having negative 74.29 meters per second squared. As simple as that. Now if we go to part C, part C is saying a stone is dropped from rest into a well. The sound of the splash is heard exactly 2 seconds later. Now the question is, find the depth of the well if the air temperature is 10 degrees Celsius. This question I solved it. Okay, I solved it. So I'm going just to put the video in the next one. Then same applies to part D. I solved it. Stone is dropped from rest into a well. The sound of the splash is heard exactly 2 seconds later. Find the depth of the well if the air temperature is 10 degrees Celsius. Okay, so let's first try to understand the question. So if we have a well, I'll just have a well here. Okay, and then the height of this well, I'll call it h. It's the one we're trying to find, which we don't know. And then they are saying that a stone is dropped. So if this is the stone, there is water here. Okay, so now the time it takes for this stone to reach here, okay, that is what we are going to call T1. I would note that one as T1. Then again, there is a time which it takes for this sound to travel from this level all the way to the top where the person is. So this total time, which is 2 seconds, it was the time, the addition of the time it took from this for this stone to reach down here, and at the same time the time it takes for the sound to travel from this point all the way to the top part. So meaning we've got 2 times, we've got T1 and T2. So T1 is the time it takes for the stone to reach on the bottom of the well. That is T1. So if I add T1 plus T2, T2 is the time it takes for it to move from the bottom here all the way to down. That is the sound now. So when I add T1 plus T2, I'm supposed to get 2 seconds. And I do know that I want to find the h. So I started from rest, meaning the initial velocity is 0. So d is equal to v initial times t plus half gt squared. Since the initial velocity is 0, this is going to be cancelled out. So I'll have this d is the same as h. So I'll say h will be equal to half gt squared. Now in this case, which t are we talking about? We're talking about T1. Okay, so I'll say half gt1 squared. Now since I don't have h, I also don't have T1, I'll call this equation 1. Again, the speed of sound in this case, the velocity of the speed of sound, we do know that the velocity is given by distance over time. Now in this case, this distance is the h, and my goal is to make this h as a subject of formula. So So I'll say D will be equal to V. This is now the speed of sound in air. So the speed of sound in air is going to be now T2. The time it takes for the sound to travel from this part here all the way to go up, that is T2. So I'll say times T2, like that. Okay, so D is the same as H, so I would say like that. Okay, now I have got two formulas which I have to put them here. So I'll say my H will be equal to half GT1 squared. Another one is that H should be equal to V times T2. Now we can make T1 as a subject of formula, or even just T2 to make things simple. Let's make T2 as a subject of formula in this formula. So at this point I will discover to say the velocity, the H, this H and this H, they will be the same. Okay, so I need first to find T. So let's make T2 as a subject of formula. T2 will be equal to 2 minus T1, meaning that where there is T2 in this formula, initially these two H, we are supposed to equate them equal to each other. What do I mean? I'll say half GT1 squared will be equal to V times T2. So where there is T2, let's replace it with 2 minus T1. Okay, so I'll say half GT1 squared is equal to V, open brackets, where there is T2 we put 2 minus T1. Now that we have got T1 both sides, the left side and the right side. But again, we've been told that find the depth of the well if the air temperature is 10 degrees. So I need to find the velocity when the air temperature was 10 degrees. And I know that V is equal to 331 times the square root of the temperature divided by 273. So this temperature we have to change it to Kelvin. So I'll say 273 plus the degrees, which is 10. That will be now the temperature in Kelvin. So I'll say 273 plus 10, which is 283. So my V will be equal to 331, the square root of 283 divided by 273, like that. So 283 divided by 273, the answer I get is 1.0366. I get the square root is 1.018 times 331. I'm getting 337. So the velocity now which we are talking about right now is 337 meters per second. Okay, now that I have my velocity, I can plug in the values to find first the time. Now when I find the time, I need to come back and use this. Why am I going to use this? I cannot use this because this stone was falling under the influence of gravity, so gravity has to be included. That's why I'm going to use the first one. Okay, so I've equated this distance equal to each other, and then I'm going to say half GT1 squared is equal to, my V is 337, open brackets, 2 minus the T1 I don't know. So I can now plug in half. Since it was going down, the G will be positive because it was going under it was going toward the gravity, so it will be 9.8. Then T1 squared is equal to, if I multiply these two, I'll say 337 times 2, which is 674. Then minus 337 times T1 is 337 T1. So now I can get rid of this. Then I'll say half times 9.8 is 4.9. T1 squared is equal to 674 minus 337 T1. I can clearly see that I've got T1 and just T, meaning that is a quadratic equation. What's the best thing to do? I'm going to shift these to go to the left hand side. Okay, so I'll have 4.9 T1 squared plus 337 T1 minus, because this one when it goes this other side is going to be minus 674 is equal to 0. Now that I've got this equation here, I can use quadratic equation to find the value of t. I no longer need this. Okay, then I also no longer need this. Let me just push this part here to be on top here. So using quadratic equation is going to be t is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So this is my a, this is my b, and this is my c. So t will be equal to negative 337 plus or minus the square root of 337 squared minus 4, the value of a is 4.9, then c is negative 674, like that. I divide this by 2, a is 4.9, like that. So I have t to be equal to negative 337 plus or minus, what is in the square root there? If I do 337 squared, negative and negative, this negative here and that negative will be plus. So I'm going just to say plus, then I'll say open brackets 4 times 4.9 again times 674, then I close the brackets. So I'm getting 126,774.4. So now I get the square root of this. I'm getting 356.06, which is the same as just 0.1. Then I divide this by 2 times 4.9 is 9.8. Now I'll create space here on top. So I'll have t will be equal to negative 337 plus 356.1, divide this by 9.8, or another value for t will be negative 337 minus 356.1 divided by 9.8. Okay, so what will be the value for t? I'll just do it direct. So it will be negative 337 plus 356.1. I'm getting 19.1. 19.1 divided by 9.8. So I'm getting t1 will be equal to, now this is t1 which we're finding, 1.94. Okay, 1.94 1.94, or I can just round it off and say 1.95 seconds. This one will give me negative, but time cannot be negative, so I'll just leave it that side. It's going to be negative 337 minus 356.1 divided by 9.8. So I'm getting negative 70.72 seconds. So the time, which is t1, is now 1.95. Now, since I have the formula which I can use to find the height, now that I have my t1, I said we are going to use the one which is having g because it was in a free fall motion, so it was falling under the influence of gravity. So it will be half gt1 squared. So half 9.8, then t is 1.95. Now I square it like that. So my height of the well is going to be 0.5 is 1 over 2 times 9.8 times 1.95. 1.95, I square it. So I'm getting my answer to be 18.6. Let me redo it. I'm saying we have 1.95, I square it, times 9.8 times 1 over 2 is 0.5. So I'm getting 18.63 meters. So So this is the height of the building. So now so this is the answer for this question. So you have first, for these 2 seconds, it was the total time t1 plus t2. That is the key point which you have to take note there. Okay, then you have to find t1, because we have to use this formula where there is g, because the stone was falling under the influence of gravity. This question is under standing wave. So let me read the question for you. A stretched string fixed at each end has a mass of 40 grams and a length of 8 meters. The tension in the string is 49 Newton. Determine the position of the node, antinode, for the third harmonic. Determine the position of the nodes and antinode for the third harmonic. But B, what is the vibration frequency for this harmonic? Now, the moment when you read the question, if they're not mentioning anything about harmonic, then just know that you are talking about the first harmonic. But in this case, they've specified to say we are talking about the third harmonic. So if you are talking about the third harmonic, then the number of loops is equal to 3. Okay? At the same time, the number of loops is equal to the antinode. So in this case, if I have got 3 antinodes, since we are saying that the number of loops is represented by n, so n is equal to 3. If n is equal to 3, we have got 3 antinodes. Okay? Now there is a formula which you have to know. If you have got 3 antinode, antinode is given by node plus 1. Minus, supposed to be minus 1. And then if you want to start with node, node is given by antinode okay, antinode plus 1, meaning that in this case I'm going to have, if we are talking about the antinode, we have 3 antinode and we want to find the node. So the node is antinode plus 1. So antinode is 3, meaning that the node we are going to have 4. 3 plus 1 is 4. So I'm going to have 1. Let me put it here. We're going to have 1, 2, 3, 4. So if I've got 4 nodes, I expect to have 3 antinodes. So there we go. From here, 1. Okay. So now this is node, 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 node. Then this is antinode. So I'll say I'll put n here. This is a, n, a, then n. Here I'm supposed to put a, which is antinode. Then this one is n, which is node. So if n is equal to 3, meaning that we have got how many antinodes? We have got 3, and for sure here we have got 1, 2, 3. Okay, for the third harmonic. Now, after coming up with this, one thing we have to understand is that if I've got one thing here, like that, and this is the length. So standing wave is called standing wave because the length doesn't change. In this case, I can clearly see that this is just a half wavelength, meaning that L is equal to half wavelength. So what if I want to talk about the antinode in between? If this, the whole of this is half, meaning in between here is going to be 1/4, the wavelength. So what I mean is that allow me to put the antinode to be on top. So I'll put the antinode here, there, here. So this, the first one is going to be 0, that's where it's starting from. The second node is going to be length will be equal to half the wavelength. Now if I reach at this point, if this is half, this is half, then I add another one here, that is going to be 1. So it's going to be 2 over 2, which is the same as the length will be equal to the wavelength. Again, if I come to this part, it's going to give me 3 over 2. Okay, it's going to give me 3 over 2. Initially, the formula which you have to be familiar with for the node, it is n over 2 times the lambda, that is L. So I can clearly see that the first part here, I've got only n is the number of nodes. So in this case, I've got one node. So n is going to be equal to 1. That's why it's 1 over 2 lambda. Then if I come to this part, n will be equal to 2. That's why it's going to be 2 over 2 times lambda. When I come to this part, it's going to be 3 over 2. So here is going to be length will be equal to 3 over 2 lambda. Then when we're talking about the antinode is given by it's going to be, if this is 1 over 4, so the length here will be 1 over 4 lambda. Now in between 1 over 2 and lambda, what are we going to have? We expect to have 3 over 2. Now for antinode, we are dealing with the odd numbers, okay, which is 1, 3, 5, then I'm going to have 7, like that. So for this one, meaning that the first one is going to be 1 over 4. So n can be anything, can be the odd number, 1, 3, 5, 7. Yeah. So now if I'm going to have n is equal to 1, then it's this part which I have here. Then the second part is going to be L will be equal to, my n now is 3 over 4 lambda. The second part is going to be 4. It's going to be 5. So here L will be equal to 5 over 4 lambda. Now we want to find the position. To find the position of the node and antinode, we need first to find, so this one is going to be L is equal to 0. We don't have anything there. So I need to find the value of lambda. So how can we find the lambda? Now to find the lambda in this case, we are going to get this formula. I've told you to say the general formula is L is equal to n over 2 times lambda. So since we are talking about the third harmonic, meaning that n is equal to 3 in this case, and we've been told that the length is what? Is 8 meters. So I can make lambda as a subject of formula in this case. So if I cross multiply, I'll have n times lambda is equal to 2L. Let's divide both sides by n, even here by n. So lambda will be equal to 2L divided by n. So we have everything now. 2, the length is 8, n is 3. So my lambda will be equal to, I'm going to say 2 times 8 divided by 3. That is 5.33. So 5.33 meters is my lambda. So if 5.33 is my lambda, then I can now find the position. Okay? So the first position of the node, I'll start with the node. So I'll write here nodes. The first one is going to be 0. That is the first one, comma. The second one will be 1 over 2 lambda. So lambda is 5.33. Then the third one will be just lambda, which is 5.33. The fourth one will be what? 3 over 2 lambda, which is 5.33. So the final answer will be 0. Then I will say half, which is 0.5 times 5.33. That is 2.66. So 2.665 meters, comma, 5.33 meters, comma. Then I'll have 3 divided by 2 times 5.33. That is 7.995 meters. So this is the position of what? The node. The first one will be there, the second one here, the third one, the fourth one. Okay. Now to find the antinode, so I'll say the antinode. The antinode. So the antinode, the first one will be this one, 1 over 4. So I'll put here 1 over 4. Lambda is 5.33. The third one, or the second one will be 3 over 4. Lambda is 5.33, comma. Then another one will be 5 over 4. Lambda is 5.33, like that. So I'm going to have 1 over 4 times 5.33. So I'm getting 1.33. 1.3325, but I'm going just to put 2 decimal places. It's okay. So even here you can just round it off and leave the answer in 2 decimal places. So you also have 3 divided by 4 times 5.33. So it's 3.9975, which is the same as just 4.00 meters, comma. Then 5 divided by 4 times 5.33. I'll have 6.66 meters. Even here, meters. So this is these are going to be the position of the antinode. Okay, then these ones, if you want, you can round it off. This one can be 7. You get rid of this. Then this one can be 8.00 if you want to round it off. So that is it for the first part. Now the second question is saying, what is the vibration frequency for this harmonic? So since the n is 3, the time we were talking about the standing wave, I think I derived different formulas on how to come up with the first harmonic motion. I think we had 3 different formulas. So n is equal to 3, and we are saying that L is equal to n over 2 times lambda n. In this case, lambda 3. This is what we are talking about. So what I'm going to do now is I know that the frequency, which is Fn, the frequency of the unknown harmonic, is going to be given by, let's start from here. V is given by the frequency n times lambda n. In this case, we are assuming we don't know the harmonic which we are talking about, but it's 3. I'm going to plug in later. My goal is to make frequency as a subject of formula. I'll divide both sides by lambda. So these will cancel. The frequency n will be given by V over lambda n. Now from this formula here, let's make lambda as a subject of formula. So we have lambda. If I cross multiply here, I'm going to have n times lambda n is equal to 2L. Let's divide both sides by n, even here by n. These two will cancel out. Lambda n will be equal to 2L over n. So let's replace where there is lambda with this 2L over n. So Fn will be equal to V over 2L divided by n. So this is the same as Fn will be equal to V divided by 2L divided by n. So if I want to change this, I'm going to put times. So V times n over 2L, meaning my Fn will be equal to n times V over 2L. Now, one thing we have to take note here is this. Let me show you here. The V will not change. We are still talking about the same velocity, which is 343, which is the speed of sound in air. 343 we're still talking about the same velocity. But in this case, I can't use 343 because I've been given the tension and I've been given the mass and also the length of the string. So I can't use 343. I have to find the speed of wave on a string is given by V is equal to the square root of the tension force divided by the mu. Mu in this case is the linear density. Linear density is given by the mass divided by the length. Okay, so we have been given everything. We have the tension and I want to find the third harmonic. Now in this case, let's assume to say we want to find the first harmonic. So the first harmonic, you discover to say n is equal to 1. So if n is equal to 1, we'll have this. F1 will be equal to 1 then V over 2L, because 1 will not affect anything here. What if n is equal to 2? So if n is equal to 2, we'll have 2V over 2L. Now one thing here, we can see that this part will not change. Even when I go to 3, the third harmonic, it will be 3V over 2L. So this part doesn't change. This one, it doesn't change. Only n is the one which is going to change. Then I can have the general formula. I can isolate n. I can say Fn will be given by n. Then I'm going to have, then I put this V over 2L like there. Now I know that the first harmonic is given by V over 2L. So perhaps you are going to see in some books there is this formula for finding any harmonic, to say it's n times the first frequency or the first harmonic. So this formula, this is where it's coming from. Now in this case, we are not interested in this. If n is equal to 3, from here, where is it? I'm going to start from this part here. Here. So I can get rid of this. Then I can also, so what we want to find, what is the vibration frequency for this harmonic. So now from this formula, n over, or n times V divided by 2L. Now since I don't have V, I'm going to replace the V with this formula. So you are going to see this formula in different books. So I'm going to isolate this times V. So where there's V, we replace it with this. So you see this formula times the square root of the tension force divided by the mu. Now we have all the information. We can now plug in the values. So we want to find the third one. N is equal to 3. So I'll put 3 divided by 2. L is 8. The square root of the tension force, we have been told that it is 49. Then the mu. Now let's find the mu. M, which is the mass, is 40 grams. Let's convert 40 to kgs. That is 0.8 or 0.04 kgs. Then L is 8. So our mu value will be equal to say mu will be equal to 0.04 kg divided by 8. That is 0.05. 0.005. So it is in kg per meter. That is the SI units for the linear density. Now since I have everything, now it's just a matter of us plugging in the values. 0.005 like that. Okay, so we had the mass which is for linear density. We are saying 40 divided by 1000, 0.04, divide this by 8. Okay, 0.005. So F3 will be equal to, I'm going to have 3 divided by 8 because 2 times 8 is 16, so I'll divide it by 16. So I'm getting 0. I'm not going to round it off. I'm getting this times the square root of 49. In fact, inside there, I can just do it direct. I can say 49 divided by 0.005. Then I get the square root of this. Okay, so the answer I'm getting is 98 point, it's the same as 99 just. Then 99 I do times 0.1875. So I'm getting 18. So F3 is 18.56 hertz. So my calculator is having issues. Let me just turn it off and then I turn it on again. So the first part which we had was we were dividing the linear density. I want to start from there. The linear density was the mass, which is 40 divided by 1000, which is 0.04. So 0.004, 40 divided by 1000, 0.04. So 0.04 divided by the length is 8. Okay, that was just correct, which is 0.005. So what is 49? 49 divided by 0.005. Then I get the square root of this. So the answer I'm getting, I do times, then I have 3 there divided by 16. So 3 divided by 16, we are getting 18. Okay, so the answer is just okay. So the correct answer is 18.56 hertz. That is the third harmonic. Another next interesting question from a past paper is a guitar string is 90 centimeters long and has a mass of 3.6 grams. The distance from the bridge to the support post is L is equal to 62 centimeters and the string is under the tension of 520 Newton. What is the frequency of the second overtone? Second overtone. Now, this question is bit tricky because you have got two lengths, and you start thinking to say, okay, why do we have two lengths? Now, this 90 centimeters is the length of the string of the guitar, meaning this length I can use it to find what? I can use it to find the linear density. What do I mean? When we're talking about the fundamental frequency or the overtone, overtone is the same as the fundamental frequency or the harmonic. So they can say the second overtone or the second harmonic or the second fundamental frequency. Okay, now when we're talking about the second fundamental frequency, just know that the number of loop is equal to 2. The number of loop in this case, when we're talking about the normal standing wave, it is the same as the antinode. Okay, so in this case, what I'm going to do is, if I'm finding the second overtone, what we should know is we're going to have something like this. If n is equal to 2, meaning that L will be equal to n divided by 2 times lambda n. Now n is equal to 2, but I want us first to derive the formula. Okay, so I can make lambda as a subject of formula here, or we know that V is equal to the frequency. Now in this case, it's going to be the frequency n, which we don't know. Which overtone are we talking about? We are talking about n is equal to 2, but for now I'll just say fn, then lambda n. Make f as a subject of formula. So divide both sides by lambda. V will be divided by this. So we'll end up having this. We'll have V, then lambda. Here now I can make lambda as a subject of formula because I have this L. Now this L which we're talking about here, it is this L. Because 90 centimeters is the one I'm going to use to find the linear density, because I know that the velocity, the speed of sound in a string, or the speed of wave on a string, is given by the force divided by the linear density. Now the linear density is the mass divided by the length. Now this length is 90 centimeters because it's the length of the string of the guitar, but we have the mass. So now here I'm going to make lambda as a subject of formula. So it's going to be lambda n is equal to 2L. Now I have got n, sorry, because this is n. Let's divide both sides by n, even here by n. These will cancel. Lambda n will be equal to 2L divided by n. So we replace lambda with 2L over n. So I'll say 2L over n. I can get rid of this. So I'll end up having the fundamental frequency to be V divided by 2L divided by n. Then it's the same as V times n divided by 2L. Then this is the same as NV divided by 2L. Now this is the formula I want us to use. So V is given by the square root of, I don't have V, but I have the tension force and also the mass and the length of the guitar, the string of the guitar. So I can go ahead and now say this Fn is going to be n divided by 2L times V, where V is the square root of, so I'll say n 2L, V is the square root of the tension force divided by mu. Now let's go ahead and find mu. Okay. In a case where you have been given the first fundamental frequency, just here, before I go any further, we are saying Fn is equal to n over 2L times V on top there. Okay. If n is equal to 1, what we need to understand is that if n is equal to 1, we'll have 1 times V is V over 2L. Meaning that I can write this as n open brackets V over 2L. I know that V over 2L is the first fundamental frequency. So another formula for fundamental frequency can be given by this, n times the first fundamental frequency. This is also very important. Another formula which you need to know is that one. Then another one is the same one, where you have V, NV divided by 2L. So these are the main three formulas which you need to know under fundamental frequency. So let's go ahead and now find the answers. So let's plug in the values, but first let's find the linear density. We are saying that linear density is given by the mass. Now the mass in this case is 3.6. I'm going to convert this 3.6 divided by 1000, which is going to be 0.0036. Let's divide this by the length. The length is in centimeters, 90 centimeters. We divide it by 100 to convert it to meters, which is 0.9. So my linear density is going to be 0.0036, 0.0036 divided by 0.9. That is 0.004. Now it's kg per meter, because mass is in kgs. Then mass is in kgs, and the length is in meters. That's why it's kg per meter. Okay. So now that we have the linear density, we can go ahead and find we know that we are finding the second overtone, n is equal to 2. So where there is n, we will put 2. So I'll say f2, n is equal to 2. The length now, the length which we are talking about down here is now this one, which is 62 centimeters. So I'll say 62 divided by 100, which is 0.62. Then this times the tension force is 512. The linear density is 0.004, just like that. So the second overtone is going to be, I think the best thing to work out to do this, I can just say 2 divided by open brackets, then 2 times 0.62. Okay, so the answer I'm getting 1.6129. I'm not going to round it off, okay, because I want to get the accurate answer. Then times, now what is 512 divided by 0.004? Then the square root of this, which is I'm getting 360, sorry, I'm getting 360.55. We have 35, then 275. Then now I multiply these two. So the second overtone will be equal to 360.5551275 times 1.6129032226. So I'm getting 581.54 hertz. So that is my second overtone. So that is it for this problem. So I have another interesting question, and this question is from waves. I think if you manage to watch the video on a tutorial sheet, that should be 3 or 2, but it should be 3. Yes, 3 question. I don't know if it's question 3. Tutorial sheet 3, question 3 for physics. It's just basically the same concept here. So the question is, a circus performer stretches a tightrope between 2 towers. He strikes one end of the rope and sends a wave along it toward the other tower. He notes that it takes a wave 0.800 seconds to reach the opposite tower, then 20 meters away. If a 0.00 meters length of the rope has a mass of 0.35 kg, find the tension in the tightrope. So basically here is just a simple principle which we have to apply. So here is a person, okay, let's say that this person is standing, this is the tower, okay, so let's say here is another tower to the other side. So you strike, there are going to be a wave which is going to be generated. Okay, now we have been told that we're going to have the speed. Now when we're talking about the speed of the wave on a string, we are always talking about this, the tension force divided by mu, where mu is the linear density. It is given by the mass divided by the length. In this case we have the length, okay, the length of the slope is 1 meters and the mass is also there, so definitely we can clearly see that we have what, the speed of wave on a string. Okay, now our main interest here is we want to find the tension force. Okay, so one thing when you are trying to create a wave, okay, we are trying to create a wave, there is a formula which you have to know. The velocity is given by 2n times d divided by t. Let me explain now here. So n is basically the number of rounds. Number of rounds. Sometimes if you are lucky, if they give you a question, they will specify, they will give you the number of rounds. But in this case, we have got no, for us to know that we have got one round, when you generate a wave has to come here and go back to that side. That is one round. In this case, we have been told that the wave only went to the other side, it didn't come back. So the number of rounds in this case is just half. So n in this case is going to be 1/2. That is half. Now these two, it just represent for us the distance. Okay, for us to move from this point all the way to that point, it is the same distance, this one. Since we are saying that one round is from when you come there then you come back, that is one round. So even distance has to be doubled. That's why we have 2 here. So that's the meaning of 2nd. So this 2 is just basically for the distance. We are doubling the distance, because for us to have one round we need to go and come back. So that's why it's 2nd, where n in this case is the number of rounds. So in this case it just went to the other side, it didn't come back, meaning the number of rounds is just half, because for us to consider one round it has to go and come back. So it just went, it didn't come back. So n is equal to half. Now we want to find the tension force. So V, it can be replaced by the square root of F divided by mu. Let's first find the mu value. So mu is the mass is 0.350, the length is 1.00. Therefore the mu is just 0.350 kg per meter. As simple as that. Now let's replace V with the square root of F. So I'll replace V with the square root of F over mu is equal to, I have 2nd divided by T. We have everything. Let's square both sides to get rid of the square root. Okay, allow me to put this just here, and I can get rid of this. So I'll end up having the tension force divided by mu to be equal to these ones. If I square them, it's going to be 2 squared is 4, n squared is n, d squared is d squared, t squared is going to be t squared. Meaning I can cross multiply. The tension force will be equal to mu times that is the same as I'll have 4 n squared d squared times mu divided by t squared. Let's try to plug in the values. This t is squared. Okay, t is now down. So the tension force will be equal to 4. The n now, n is the number of rounds. We say it is half, but we have to square it. D is 20, but we have to square it. Mu value is 0.350, but we don't have to square it. The time is 0.800, but we have to square it. So let's see the tension we're going to have. So our Ft will be equal to, now if I say 1/2, now I square it, is 1/4. 1/4 times 4 is 1. So it's going to be 1 times 20 squared times 0. Times 0.3, I'm going to say 20 squared. Okay, 20 squared times 0.35. Okay, 0. So I'm getting, I'll say that is going to give me 1, because 4 times 1/4 is 1. Then 20 squared times 0.350, that is 140. Now this 140 divided by 0.800, now we square it. So the answer I'm getting is 218. 218.75 newtons. So that's the answer for this question. So I'm now in 2022 physics. This is it was the final exam, question 4B. So question 4b, there was part A. Oh, but this is part B. Question 4, B and C. It's the one we are going to answer here. So the question reads, a 0.25 kg block attached to a light spring oscillate on a frictionless horizontal table. The oscillation amplitude is equal to A is equal to 0.25 meters, and the block move at 6.00 meters per second as it passes through equilibrium at x is equal to 0. The first question is, find the angular frequency. So the angular frequency, as long as you have the formulas for angular frequency, the main ones, I think there are two. Yes, there are two. I can say there are three, but let me just say there are two, the main ones. The three that the third one is just uh, I don't know if you can be using it, I don't know, but the main ones is just this and that, the root of k over m. So you check, in this case, have we been given the k value? No, we don't have the k value. Do we have the frequency? No, we don't have the frequency. So I have got two unknown variables. I don't know the angular frequency. I also don't know the k if I'm trying to use the second formula. The first formula, I don't know the angular frequency, I don't know the frequency. But according to the data we have, is it enough for us to have the frequency? Okay, because the frequency is given by 1 over period. Do we have period? No, so this can't work, meaning that this formula, it can't work here. It can't. How can I find k? Using this information, I have the mass, I have the amplitude, I have the x. X is equal to 0. Yes, yes. So now at x is equal to 0, at x is equal to 0, we know that the mechanical energy, the total energy, should be the elastic potential energy plus the kinetic energy. So this is half Ka squared, elastic potential energy is half Kx squared, plus this is like that, mv squared. One thing we have to understand, we are talking about at x as it is passing through x is equal to 0. When x is equal to 0, we don't expect this. So we have half Ka squared, half mv squared. Let's cancel half. So we have now Ka squared, mv squared. Our goal is to find the k value. Divide both sides by a squared. So we have k to be equal to m v squared a squared. Let's find k value. The mass we have been given is 0.20. What else? The velocity is 6. We square it. The amplitude we have been given 0.25. We square it. What is our k value? So our k value will be 0.250 times 6 squared. I divide this by 0.25 squared. I'm getting 144. So 144 Newton per meter is my k value. Now that I have my k value, I believe I can use the second equation to find the angular frequency. So I'll say the square root of the k is 144. The mass is 0.250. Okay, so what is the angular frequency? 144 divided by 0.250. Then I square root this one. I'm getting a 24. Okay, I'm getting my angular to be 24. 24 rad per second. Now we can go to part B. We can go to part B. Part B is saying calculate the total energy of the spring. The total energy is given by the formula I gave you at first. The total energy is half Ka squared. So the K is 144, A is 0.25. So the total energy is 0.5, because 1 over 2 is 0.5 times 144 times 0.250. Okay, so 0.25, so A has to be squared. 0.25 squared times 144 times 0.5, 4.5. So I'm getting my answer to be, the total energy to be 4.5 joules. Now the last question is, what is the Bloch speed when x is equal to negative a over 2? What will be the speed? Now for us to find the speed, in this case we have to come out from, we need to start from the mechanical energy formula. But allow me to put this k here because it's very important for us to keep it. It will help us. So now I can get rid of this. So we have the total energy is given by the elastic potential energy. Let me just put the elastic plus the kinetic energy. Total energy is half Ka squared. Elastic potential energy is half Kx squared. Then this is also half mv squared. But we can clearly see that half appears everywhere. We can cancel it. We end up having Ka squared to be equal to Kx squared plus mv squared. We have been told that what will be the speed, and our interest in is in what? The velocity. Let's shift this to the other side. So it will be Ka squared minus Kx squared is equal to mv squared. Let's divide both sides by m. So here by m, here by m. So m and m will cancel. We'll have v squared to be equal to Ka squared minus Kx squared divided by m. But we've been told that where there is x, put negative a over 2. So let's go ahead and do that. Initially this is going to be the square root now. So it will be the root of where there is k, where there is x. So I'll say this, where there is x we put negative a over 2, but we square it, then divided by m. Negative and negative will give us positive, meaning that this formula now will be like this. The speed will be equal to the root of Ka squared plus, because negative and negative, Ka squared, because now this is squared, then divide it by 2 squared is 4, then everything again divided by what? M. Let's try to plug in the values. So we have the K value is 144. Okay. The A value is 0.25 plus the K 144. The A, so this has to be squared. The A is 0.25 squared. Then divide this by 4. Again, everything divided by the mass. The mass is 0.250. What will be our velocity? So we have 144 times 0.25 squared. I'm getting 9. Meaning that now I have the square root of this is 9 plus, what is 144? Initially it's going to be, we are saying 144 times 0.250 now squared is 9. So 9 divided by 4, which is 2.25. Then divide this by 0.250. We expect our velocity to be 9 plus 2.25. I'm getting 11.25. Divide this by 0.250. I'm getting 45. The square root of 45 is 6.71. 6.71 is 6.708. I've just rounded off to 6.71 meters per second. So that would be the velocity when x is equal to negative a over 2. As simple as that. Okay. Now the last question now is briefly explain. It's just 2 marks. You just need to explain. Briefly explain how standing wave in air column are produced. So standing wave can only be produced in air column. We're talking about the air column right now. Okay. So if we tend to have a pipe that is more like air column, let me just give you and let's assume that it is just open at one end. So if inside here there is fluid, for us to produce a standing wave, one thing has to happen there. Okay, so there's supposed to be an interference between the sound wave, okay, in opposite direction. So as long as there will be an interference of sound wave in opposite direction, then a standing wave in air column is going to be produced. What do I mean? So if this is what we have here, and then you know that standing wave, it will come as like that. Like that. So now there is an interference which is coming from this direction. They are meeting there, so they are going to interfere at a certain point. Okay, so the best explanation you can give is standing wave can be produced as a result of the interference between the sound wave traveling in opposite direction. As simple as that. Sound wave can be produced as a result of the interference between the two, or you can say sound wave. I'm making another mistake again. I'm saying standing wave can be produced as a result of the interference between the sound wave traveling in opposite direction. As long as that sound is traveling in opposite direction, they are going to interfere with each other. As long as they are going to interfere, then we expect the standing wave to be produced at that point. Okay, so let me write this. So I'm saying standing wave standing wave can be produced in air column if there is an interference of sound, or the interference between, like, let me just say interference between sound wave traveling in opposite direction. So in that case, then the standing wave in air column is going to be produced. You have two waves moving in opposite direction. They are going to interfere with each other, thereby resulting in what? The standing wave in air column. So that is it for this one. So I have this question, which is saying, the first question is saying, state two fundamental properties of a simple harmonic oscillator. State two fundamental properties of simple harmonic oscillator. So just two properties which you know. So when we're talking about simple harmonic motion, what do you know? I can give an example of, let's talk about the spring. Okay, so as you are trying to stretch the spring using the applied force, the force that makes the spring to go back to its equilibrium position is what we call the restorant force. Okay, so one thing we have to understand is that the first property we can talk about the restorant force. Okay, we can say the body has to be worked on by restorant force. For this system to happen, the restorant force has to be there. So we can say the first one, the body, okay, has to be worked on by the restorant force. We can't have a simple harmonic motion if we don't have the restorant force, because the restorant force is the force that makes the system to start now going back and forth. Okay, what another example can we talk about? So when we talk about this restorant force, we are saying is kx. Okay, then you can replace force with mass times acceleration. Let's make a as a subject of formula. I want us to see something. What's another property? I think we can get it from here. So we can see that um, the displacement and the acceleration is direct proportion to each other. What does it mean? If the x increases, a has to increase. That's why when you stretch the spring reaching at the maximum position, you discover to say you are going to have the maximum acceleration. Why? So we can say another fundamental property is that the acceleration of the body is always direct proportion to the displacement. Okay, that is another principle which we can just come up with. So you can write it there. The acceleration is direct proportion to the displacement. Okay, then we can also come up with another one. You know, when you're talking about when you are stretching this sometimes, but this is not always, you discover to say the system will need some kind of mass. Okay, so we need a mass for this simple harmonic motion to happen, because we need to attach something here, then we start now stretching. But not always, but you can just use those two. Those are the main ones, the one for the acceleration and for the restorant force. That is it for the first part. Now let's go to part B. Part B is very much interesting. So we have the question, which is a simple harmonic oscillator is described by the equation x is equal to 0.250 meters cos x over t over 8 times t. So this is the position as a function of time. One thing we have to remember is that we have three formulas before we even solve these questions. We have three formulas. The position as function of time is given by this. I'm not going to waste time to derive these formulas, but I believe if you manage to watch my video under the position, velocity and acceleration as a function of time, I derived these formulas. But here I'll just give you the three main formulas which you need to know. Okay, so the position as a function of time is given by a cos angular velocity or angular frequency times t. Then the velocity as a function of time is given by negative a angular frequency, then sine this and that. Then the acceleration now as a function of time is given by negative a, this, it has to be squared, sine, or it has to be cos now because the first one is in sine. So have this. Okay, now what we're going to have here is, I can clearly see that we don't have the time, but our main focus here is we want to find the amplitude. So the first question here is find the amplitude, the frequency and the period of the motion. Okay, find the amplitude, the frequency and the period of the motion. So let's start with the amplitude. So the amplitude here, we know that the number in front of cos is the amplitude. Okay, The number in front of cos is the amplitude. So from our equation here, this is our equation. Okay, we can clearly see that this is my amplitude. So I'll just say my amplitude is 0.250 meters. As simple as that. The second one is the frequency. Okay, the frequency here, we have the angular frequency, which is like this. The angular frequency is the number in front of t, this number. So that is the the angular frequency. So now in this case, but before I explain, sometimes you are going to be given something like this. Let me just show you this. What if you have, I want you to be familiar with all the cases. Then you have pi over maybe 5 t, then plus, maybe you also have another one here, let's say 2 pi. So this one is what we call the phi. So in a case where you are going to be given a phi there, even when you are writing these formulas, you need to add the phi. Okay, if you've been watching my videos, I believe you know that. So now the angular frequency in this case is pi over 8. Okay, this number here. Now we want to find the frequency. Remember that this can also be given by 2 pi f. Okay, so I can divide both sides by 2 pi, even here by 2 pi. So frequency will be, the angular frequency is pi over 8, then divided by, we have now 2 pi. So this is the same as pi divided by 8 times 1 over 2 pi, like that. Then we can cancel the pi. Frequency will be equal to, we'll have 2 times 8 is 16, so it's the same as just saying 1 divided by 16. That should be 0.0625 hertz. As simple as that. Now sometimes if you don't want to do this complicated stuffs, what you can do, guys, is you can just plug in the values just like the you say, and then here you can just find the angular frequency. You can say the angular frequency. What you can do is this. You can say that the angular frequency is, what is pi divided by 8? That is 0.393. That is now rad per second. Okay, now since we have this 2 pi f, you can just say f will be equal to this divided by 2 pi, which is, this is going to be 0.393 divided by 2 pi. Then the frequency will be 0.393 divided by 2 pi. You end up getting the same answer, 0.0625 hertz. As simple as that. Now that we have the frequency, what is a period? Period is given by 1 over frequency. So 1 divided by the frequency is 0.0625. So we expect our period to be, to be 1 divided by 0.0625, 16 seconds. That's the period. Okay, now another thing we should have to know here is this. Let me just put the answers which we have found here. I have to put this angular frequency. I'll just push it here. I'll just push it here. Okay, yeah. Then the frequency, I'll also push it there. as well as the period. The period, I'll also just put it here. Now let's go ahead to part 2. Part 2 is saying find the maximum magnitude of the velocity and the acceleration. When you hear the word magnitude, even if the answer is negative, just get it as a positive. Okay. Now, one thing we have to understand is this. When we're talking about the maximum acceleration, I believe you know this formula. The maximum acceleration is given by negative k, okay, negative k over m times a. That is the maximum acceleration. And that one we know it already. Okay. What about the maximum velocity? The maximum velocity, if I'm to remember very well, it should be or I can't remember the formula for the maximum velocity, but what I'll do is I'll just derive it. I want to show you the relationship which is there between these formulas and the maximum velocity and the maximum acceleration. So when we're talking about the maximum velocity, what we need to know is that x is always 0, meaning the mechanical energy is equal to the kinetic energy. Because I don't have the x, so the potential energy is 0. So it starts from here. Half ka squared is equal to half mv squared. Okay, yes, so I can cancel half. I'll end up having ka squared is equal to mv squared. Divide both sides by this, both sides by that. So I'll end up having v squared to be equal to ka squared divided by m. So if you're not able to remember the formula like the way I am here, I can't remember the formula for the maximum velocity. I just need to derive it. But if you can remember, then that's just okay. Okay, so I'll end up having v squared to be equal to k divided by m times a. I get the square root both sides. I'll have the square root of k over m, then times this a is squared, so a is squared. But what I can do here is I can just rewrite this formula as, I'll put this formula to be my v max to be equal to the square root of k over m times, then I will remove this in the square root because the square root of a squared is just a, so I'll put a here. Okay, so these are the formulas I wanted us to know. These two. Let me just shift this on top here. Now that I have these formulas, but let's now try to see. I don't have k here, and I can't use these formulas because I don't have k. But one thing we have to remember is the angular velocity, the angular frequency, is also given by the root of k over m. What does it mean? Okay, meaning that where there is the square root of k over m, I can replace it with the angular frequency. So I'll start with what? The velocity. So the velocity is going to be the v max is equal to the square root of k over m. The square root of k over m, I'll replace it with just the angular, then times a. Now this is exact as when you want to find the maximum velocity, you have got the angular velocity and the amplitude. You just get these two. Then the acceleration is going to be, you get these two. Okay, so that's the relationship which is there between these formulas and these two formulas for the maximum and the maximum velocity and the maximum acceleration. That is very, very important. Okay, so if I'm to get just this and that, I'll be able to get the maximum velocity. Therefore my velocity will be the w. Now the question is find the magnitude. I'm not interested in the negative. The w is we found that it's 0.393. the amplitude is 0.250. so the velocity will be 0.393 times 0.250, which is 0.0983 meters per second. That is the maximum velocity, the magnitude. Okay, so even if the answer, even if you, when you just get this, that's the velocity. Now we want to get the magnitude, that's why I'm not including the negative here, it's just the magnitude. Let's find the acceleration. Okay, so the acceleration now will be the maximum acceleration will be equal to negative a over that, which is just basically the same as it's the same as just getting this. Now what I mean here is this, if I'm to make, I have this, if I'm to make k over m as a subject of formula, then this is going to be squared. That's why it's going to be this, and we end up having negative this, then 0.393. Now we square it. What will be our answer? So our answer will be 0.393 squared times 0.25. That should be negative 0.0386 meters per second squared. Now you are still shocked. I said you have to ignore the negative, so this is not the final answer. The magnitude, then you say the maximum acceleration will be equal to, you just get the positive part because we want to get the magnitude. So that's the answer. Now let's go to the last part, which is what is the position, but I don't have to remove this. The position, we want to find the position when t is equal to, so I'll just use that formula. What is the position? What are the position and velocity of the object after 1 second? So the position will be x as a function of 1, then the amplitude is the same, 0.250, because the angular velocity, the angular frequency is pi over 8, then the time is 1. Now you need to be careful here. You need to put your calculator in LAD, because the theta here, the angle is in LAD. So you need to put your calculator in LAD. Okay. So I'll put my calculator in LAD. Okay, so I'll say what is okay, I'm going to say 0.25 cos, open brackets, then pi divided by 2, because times 1 will not affect anything. Pi divided by 2, or divided by 8, sorry, then I close the brackets. So I'm getting the position as a function of time to be 0.23. Now this position is in meters. Then the velocity, now I'll say v, the formula is negative a this, then sine that. So I'll just say as a function of 1, negative 0.25, then that is we said that was 0.393, so I'll just put 0.393 sine 0.393 times 1. So times 1 will not affect anything, it's just the same as just that. So I'll say 0.25 times 0.393. I'm getting, so it's going to be negative 0.09825 sine 0.393, like that. So remember to put your calculator in large, so it's going to be 0.09825 sine 0.393. So I'm getting negative. Now this is going to be negative because the formula has negative, negative 0.0376. So that should be meters per second. Sometimes you come across the same format of the question, but they're going to ask you to find maybe the formulas of the acceleration and the velocity. It will end here. It will end there. In a case, they will not give you the time. They'll just say, what are the formulas of the velocity as a function of time? And you've been given the first one, just like that. So you say v, okay, as a function of time will be equal to, then you have to get the same things. In this case, it's going to be 0.09825. Then you say sine. Then you just copy what is here, pi over 8t. That is the formula for the velocity. For the acceleration, you need just to plug in. So when you this one, so for the acceleration, this is going to be that you have to multiply them. Like you have to find the single answer which is there, and then put it the way it is. If you are going to be given phi, you need also to include phi in your formulas. Okay, so this was the most interesting one. Now the same concept again. Another question came in 2023. The same concept, okay, which is here now. So the question here is saying a particle of mass 250 grams oscillate freely on a frictionless horizontal surface, and displacement of the particle is given by this formula here. And this question came exact, the function, it was just exact as the one we are from solving. The one we are from solving, I think it came in 2021. Yeah, 2021, 2022, somewhere there, but it should be 2021. So this is for 2023. The question was, what is the spring constant of the spring to which the particle is attached? In this case, you need just to focus on the angular frequency. You know that the angular frequency is given by the square root of k over m. Again, the angular frequency is also given by 2 pi f, but I can't use this because there is no relationship between this formula and the k. I'll use the first one because there is k. I have the mass. So this mass we have to divide it by 1000. Okay, so in 1 grams or in 1000 grams there is one what? There is 1 kg. So gram and gram will cancel. So I'll end up having 250 divided by 1000. 250 divided by 1000, which is 0. Which is 0.25 kgs. So now we want to find the k value. Let's square both sides. We know that the angular frequency is the number in front here, which is pi over 8. So I'll say we can just plug in the values, it's fine. Anyway, let's just square both sides to get rid of the square root. So it will be this k over m. Then we cross multiply. K will be equal to this, that. K will be equal to the angular frequency is pi over 8 squared. The mass is 0.25, like that. What would be our k value? So we have pi divided by 8. The answer I find, I square it, times 0.25. So the k value is 0.0386 Newton per meter. Exactly. Now here we are saying, let me just redo it, maybe I've made a mistake. Pi divided by 8, then times 0.25. It's giving me a different one. Okay, my calculator is in large and I have to convert this because I'll keep on getting wrong answers. So I have to put in degree. Okay, so we are saying pi divided by 8. Okay, this answer I have to square it times 0.25. Okay, it's the same one. So it is 0.03855. So I've just rounded off and say 8. This is 8, then 6. So that's the answer for that question. So I believe if you come across any type of this question, you'll be able to answer it. So that is it for this one. Another interesting question which is here, and I received this question from different students sending in my inbox, knowing on how they can solve it, and come on guys. So now this question, the information they gave you, it wasn't enough. I believe the people who wrote this paper, I think this came in 2022, I believe the people who wrote this paper, they gave them the change in x and the change in y. So I have my change in x, which they gave them in the final exam. So the change in x is there and the change in y is there. So this is the question. So the question is a particle floating on a disturbed water surface undergoes a motion represented by the following diagram. Given that the frequency of oscillation of the particle is 8.00 hertz, that's the diagram we can see, guys. Then the first question is calculate the speed of the water wave. Then 2 is saying how long does it take the particle to perform one complete oscillation. Okay, so I have this interesting question which came in 2022 final exam, 2023, sorry. So now this question is very interesting in such a way that we need to think. So you need to think as you are solving this question. Okay, so the question is, that was question 1. An object executes simple harmonic motion with an amplitude m. At what values of its position does its speed equal half its maximum speed? Part 2. At what values of its position does its potential energy equal to half the total energy? So a 2022 paper, question 2a. The question says, a small source emits a sound wave with a power output of 80 watts. Find the distance at which the sound intensity level is 40 decibels. 6 marks. Again, when you're solving these questions, it's very important for you. Okay, so now I have another interesting question which is from 2023 exam. That was question 4c. The question is saying a horizontal spring attached to a wall has a force constant K is equal to 8.5 times 10 to the power 2 Newton per meter. A block of mass M is equal to 1.00 kg is attached to a spring and rests on a frictionless horizontal surface. The block is put to a position X is equal to 6.00 centimeters from equilibrium and released. Part A. Write an expression in terms of time for the position or displacement of the mass as it passes or as it oscillates starting from X. Part B. Find the speed of the block as it passes through the equilibrium position. Part C. What is the kinetic energy of the block at X is equal to 3. Okay, so now it's very important for us first to, okay, so this is still 2023 paper. That is question, I don't know if it's question 2 or so, a very simple question, actually direct question. So the question is, a wave of amplitude 0.30 meters interferes with a second wave of amplitude 0.2 meters traveling in the same direction. So they're traveling in the same direction. So the first question is, what is the largest resultant amplitude that can occur? So it's like you have this. So these are traveling in the same. So now let me give you just two. I'm going to give you two scenarios. So the first one, the amplitude. So we are saying this is moving like that. So the amplitude, we have been told that the amplitude for the first one is 0.3. So now for the second one, is 0.2. So that's 0.2. The question is, what is the largest resultant? The largest is just to add this and that. So it will be the amplitude 1. So the amplitude largest will be equal to the amplitude 1 plus amplitude 2. Amplitude 1 is 0.3, then 0.20. So the largest amplitude will be 0.50 meters, meaning that now the amplitude will be. So now what do we say on that? We have constructed. And then the second one, they're saying the smallest is now 2. We subtract it. So it will be A1 minus A2. 0.3 minus 0.2. 0.1. That is the smallest. 0.1. Then under what condition will the maximum and minimum arise? For us, the maximum meaning the largest, the minimum meaning the smallest. So the maximum, for us to have the maximum, the condition has to be, we need to form what? A constructive interference. For a constructive interference, as long as constructive interference is going to be there, then we are going to have maximum. Then if we're going to have destructive interference, destructive, since another one is going to be distracted, like in this case 0.2 has been distracted by 0.3. So for the minimum is destructive interference, for the maximum is constructive interference. That is it. So let's talk about this question which came in 2023 exam. So this, I think it was question, I don't know the number of the question, but it came in final exam. So the question is, suppose a manufacturing plant has an average sound intensity level of 97 decibels created by 25 identical machines. Find the sound intensity created by one such machine. Now the best thing here to work out this problem is, we need just to find the intensity. The intensity which we are going to find when. So I have these interesting questions which came from 2023 past paper exam for physics. So the question is, the first question is, a piano string of mass per unit length 5.00 times 10 to the power. If you can see that is to the power 3, I don't know if maybe it was to the power negative 3, but if it was to the power 3, then I don't think so, because how long was that string? So I'll get this linear density to be 5.00 times 10 to the power 3 kg per meter. Okay, then we are saying that the tension is, this is supposed to be 1.350 newtons. Okay, so if you have this paper, if this was to the power 3, then when you're solving it, you're going to put it to the power 3. The tension, if it was 1000. Okay, so another question here, guys. This question came in 2023, question 1 actually, section B. A 1300 Newton car starts at rest and rolls down a hill from a height of 10 meters. It then moves across a level surface and collides with a light spring loaded guardrail. Negate any losses due to friction and ignoring the rotation kinetic energy of the wheel. Find the maximum distance the spring is compressed Assume that the spring constant is 1.0 times 10 to the power 6. Now, here is just simple stuffs, and you need just to understand simple principle. Okay, so now let's come up with free body diagram. Let's understand the question. We have a, let's say this is a car. I'll put it here. Now this car has got the weight. This one, now this is the weight, which is, so this is question 2 from 2023 paper. So the question is saying, question 2a, two springs vertically arranged in series support load, which is W, given that the two springs are not identical and have a spring constant K1 and K2. Show that the effective spring constant K for this arrangement is given by K is equal to K1 times K2 divided by K1 plus K2. We read the question again. Let's try to understand the question and analyze it. Two springs vertically arranged. Let's come up with a free body diagram. Vertically arranged in series. So these springs, they are together. The first one is there. Now we add another one, and there is a load. Okay, so I'm going to call this as K1, this as K2. What else do we know? Okay, so again, this question came in 2023. So the question is, an airplane traveling at half the speed of sound emits a sound of frequency 5.00 kilohertz. At what frequency does a stationary listener hears the sound? Part A, as the plane approaches. Part B, as the plane recedes, or as the plane moves away from you. So one thing we have to understand here, we always, when we're talking about Doppler effect, this is from Doppler effect. Doppler effect, we have the source and the observer. Okay, so now here we have been told that the frequency of the source, the moment you, so now let's solve this interesting question under Doppler effect. So the question is, hearing a siren of an approaching fire truck, you pull over to the side of the road and stop. As the truck approaches, you hear a tone of 460 Hz. As the truck recedes, you hear a tone of 410 Hz. How much time will it take for a truck to get from your position to the fire 5.0 kilometers away, assuming it maintains a constant speed? So now when we're talking about the constant speed, one thing you have to understand is that the acceleration is 0. And